We are given a curve defined by the parametric equations x equals 3t minus 2 sine t, and y is 5t plus 4 cos t. T takes any values between 0 and 2 pi. At the points P and Q, the gradient of the curve is 5 over 2. Part A, we need to show that the values of t at point P and point Q satisfy the equation tan cos t minus 8 sine t equals 5. We are given that the gradient at these 2 points is 5 over 2. So dy dx at these 2 points is given by 5 over 2. To find dy dx, we find dx dt and dy dt. X is 3t minus 2 sine t, so dx dt is 3 minus 2 cos t, and dy dt is 5 minus 4 sine t. dy dx is given by dy dt over dx dt, and this should be 5 over 2. dy dt is 5 minus 4 sine t. dx dt is 3 minus 2 cos t, and that is 5 over 2. We can cross multiply, so upon cross multiplying, we have 2 times 5 minus 4 sine t, that equals 5 times 3 minus 2 cos t. Expanding, 10 minus 8 sine t equals 15 minus 10 cos t. So the negative 10 cos t, we can move over to the left, and that 10 goes to the right. When we move 10 cos t to the left, it becomes a positive 10 cos t. We still have minus 8 sine t. And then we have 15 minus 10 on the right. So that 10 cos t minus 8 sine t is 5. And we are shown part A. Part B, we are to express 10 cos t minus 8 sine t in the form of r cos t plus alpha. R must be positive and alpha must be an angle in the first quadrant. We need to find the exact value of R and the value of alpha correct to 3 significant figures. On the right side, R cos t plus alpha can be expanded using the compound angle formula for cos. So we have R cos t cos alpha minus R sine t sine alpha. Compare that to the left, or we look at the coefficient of cos t. So we have a cos t term, and we have a cos t term. So we only look at the coefficient of cos t. Equating the coefficients of cos t, we have R cos alpha equals 10. That will give us the first equation. And we can do the same for the coefficient of sine t. The coefficient of sine t is 8 here because the two negative, they are the same. So we just grab the 8 and R sine alpha. So the coefficients of sine t. Then we have R sine alpha equals 8. That gives us the second equation. We need to solve these two equations to find the values of R and alpha. So we take the sum of squares of those two equations. On the left, we have R squared cos square alpha plus R squared sine square alpha. On the right, we have 10 squared plus 8 squared. On the left, when we factor out r squared, we have cos square alpha plus sine square alpha. That is 100 plus 64. From the fundamental identities of trigonometry, the sum of squares of sine and cos is always 1, so that r squared is 164, and r is the positive square root of 164, since r must be positive. This will give us the exact value of r. To find the value of alpha, we divide equation number 2 by equation number 1. On the left, we have sine alpha, r sine alpha over r cos alpha. That is 8 over 10. R cancels off, and then we are left with tangent alpha equals 4 over 5. Alpha is the inverse tangent of 4 over 5. And we need to find this value using the radian mode in your calculator. Make sure that your calculator is in the radian mode. And to three significant figures, that is 0.675. We can say that 10 cos t minus 8 sine t, this is r, which is square root of 164 cos t plus 0.675. That is part B. Part C, hence find the values of t at the points P and Q. At the points P and Q, you look at that 10 cos t minus 8 sine t is 5. So from part A, we know that 10 cos t minus 8 sine t is 5. And from part B, 10 cos t minus 8 sine t is square root of 164 cos t plus 0.675, and that equals 5. We only need to solve this equation. We isolate cos of t plus 0.675 by dividing throughout by square root of 164. Cos of t plus 0.675 is 5 over square root of 164. We just need to find the values of t using this. Cos is positive. This ratio is positive in quadrant 1 and quadrant 4. First, we find the related acute angle beta. That is inverse cos of 5 over square root of 164. Make sure that your calculator is in radian mode, and that will be 1.17 to three significant figures. Then we know that that is a quadrant 1 angle. So cos of t plus 0.675, the angle t plus 0.675. This is either a first quadrant angle or a fourth quadrant angle. Fourth quadrant is 2 pi minus beta minus 1.17. So we have 1.17 and 5.11. T now is 1.17 minus 0.675, or 5.11 minus 0.675. Then we found T to be 0.495 and 4.44.